Okay, so we're going to be graphing rational functions again. And this time I kind of labeled it multiple vertical asymptotes because this one is one that gets people pretty confused sometimes. So what do I mean by multiple vertical asymptotes? Well, it's a graph where we're going to have more than one place that is undefined, but is not a whole. So we saw in another video that these rational functions can have wholes and asymptotes, and they kind of are very similar. You find both by finding where the excluded values are. Now, if I'm going to be finding excluded values and it turns out you have more than one excluded value and neither one of them is a whole, well, what that means is that you have a function that has more than one vertical asymptote. So this would be one function, an example of a function that has two vertical asymptotes, for instance. All right, that would be something, he could look like that. Now the thing is, there's a bunch of different things that we could have. So I'm just going to draw a few that have two vertical asymptotes so you can see that there's more than one option here. So this is another one, something that looks like this. We could have this. And I guess basically what's the other option? Maybe something that looks like this. Okay, so there's a few ways that these can look when we have these multiple, or in this case, two vertical asymptotes. Now, it's very rare that you're going to end up getting a question that has more than two vertical asymptotes because generally that's not something that you'll see in a regular high school textbook. But we're going to decide how to figure out what the picture looks like and how to draw it. Okay, so when we're graphing rational functions, there are a couple things that we always look for. And I don't know if you remember from our other video, but what do we always look for? One thing we look for is intercepts. We look for vertical asymptotes. We look for horizontal asymptotes. We look for wholes. And then other points if necessary. Now, sometimes it's actually not necessary to find other points, to be honest with you. Sometimes you're able to do it with just this information. And again, depending on how much you know, you can work much faster than if you don't know a lot. So it's always better to understand and to know more because that'll make this work a lot easier. Okay? So that's what we're going to do. We're going to do all of these things, and then we're going to try to figure out which kind of picture, if it's similar to any of these. Okay, so here's what we're going to do. The first thing I'm going to do is find my intercepts. So to find x-intercepts, my pens are all drying out from so much math work. Okay, so my x-intercepts, everybody knows in order to find x-intercepts, you set y equal to 0. Okay? So what do? I say 0 is equal to -2 x squared plus x minus 6. Now, hopefully everybody remembers that a fraction is equal to 0 when the top is equal to 0, right? But not the bottom at the same time. Or another way to think about it is if you multiply both sides by this, x squared, I didn't really leave enough space. If we multiply both sides by the denominator, what happens is these denominators cancel out, and this side becomes 0. And now we have something that says, oh, well, that can't be true. So that means that there are no x-intercepts. And again, I could have looked at this original one, and if you again, this is a place where if you know more, it's much easier. If you remember that a fraction is equal to 0 when the top is equal to 0, you can see this top can never be 0. So that means this y value can never be 0 because that fraction can never be 0. So that would have saved us, this effort. So now we can see that there are none for this one, right? No x-intercepts. Now let's do our y-intercepts. Now how do you find y-intercepts? You let x equal 0. So here I am with my function again, this guy up here. And so I'm going to put -2 over 0 squared plus 0 minus 6. And again, these are 0, so it's actually -2 over -6. So hopefully you can see that that is a 1/3. And once again, I said that if you're talking about y-intercepts, you can say that y equals 1/3 because when you say y-intercept, it's implied that the x is 0. Or you can actually write it as 0, 1/3. I would actually accept either of these for a y-intercept. Okay, so we did number 1 on our checklist. We did the intercepts. Okay, so let me get another piece of paper here, and I'm going to run out of paper also. All right, now we're going to do vertical asymptotes. So let me rewrite my guy on this page. Okay, so here are my vertical asymptotes. Now, how do you find vertical asymptotes? To find vertical asymptotes, you find excluded values. So what are excluded values? Where denominator equals 0, right? But remember, they can't, the top, the numerator can't be 0 at the same time. So what do I mean by that? If you remember, we used an example like this. -3 and -2 would make the denominator 0. So in this one, we would, so this is just an example, right? It's not this thing. Would both be excluded values, but -2 would also make the top 0. So in this one, only -3 makes asymptote. Does everyone say what we're talking about here? So the top and bottom are 0 at the same time, means it's not the asymptote. And if you remember from our last video, that actually makes the whole, okay? All right, so let's take a look at this one. So the easiest way to see what will make the denominator equal to 0 is actually set it equal to 0. Or, you know, a lot of us, if this is factorable, which in a lot of cases, these ones are factorable. If we just factor them, a lot of us don't actually literally have to set it equal to 0. But if you want to do that, you still can. And if it doesn't factor, what it means is you have to use quadratic formula or completing the square, and it'll be some weird number, but you have to try it out anyway, okay? So let's try to factor this. We want it to be a 1, so it must be a 3 and a 2, I suppose. And we want this one positive and this one negative. Okay, so then from here, of course, if I set this denominator equal to 0, hopefully everybody can see my excluded values would be a 2 and a -3. Do you see that? And neither one of them cross out on the top like this one did. So that means that they're both vertical asymptotes. So my vertical asymptotes are the lines x is equal to 2 and x is equal to -3. So this is going to be one of those cases where we have multiple vertical asymptotes. All right, so we got our vertical asymptotes done. Now let's talk about our horizontal asymptotes. I'm just going to rewrite it because as I go down the page, sometimes it's hard to see the top. Okay, so to find horizontal asymptotes, remember, what am I going to do? I'm going to see what the value of the find value of fraction as x approaches infinity or gets huge. In other words, right? So what happens when x gets huge? So this is a case where you can kind of like pretend you're putting in a, so what is f of infinity? In other words, you know, like what would that look like? Well, hopefully everybody can see this would be huge number on the bottom, right? So what happens when you have a huge number on the bottom of the fraction and a small number on top, or a smaller number on top? It means that you have a very tiny fraction. And what is a very tiny fraction close to? Well, that's close to 0. So this one, as x approaches infinity, y is going to approach 0. So that means our horizontal asymptote is the line y is equal to 0. So whatever this value of this fraction comes out to be when you substitute in like a really big number or infinity, you know, a number close to infinity because we can't actually use infinity, but a really huge number, whatever value this fraction gets close to, that's what our horizontal asymptote is. So my horizontal asymptote is y is equal to 0. Got that one. Now, once again, I actually already did the holes, because holes would have been if I could have canceled one of these out. And since none of these canceled out, I'm actually going to put holes here because I usually find the holes while I'm doing my vertical asymptotes, and I already know that this one is none. No holes for this one, okay, because these guys did not cancel. That's how you make a hole. So this hole would have been at -2. Okay, so holes are good. Now, other points, if necessary, I'm going to wait and see if it's necessary. I'm going to start graphing this one. Okay, so this is the fun part. You ready? I'm going to take all this information that I had, and I'm going to start to graph. So let me get a clean sheet of paper here, and I'll write down what my function was once again. My function was -2 over x squared plus x minus 6. Here he is. All right. So let's start by putting in our vertical asymptotes. They were x is equal to 2 and x is equal to -3. So I'm going to graph those in. And they're vertical lines. I write them in as dashed lines because then I, remember what they are in my graph. So this is the line x is equal to 2 and x is equal to -3, right? Vertical lines. I'm going to draw in my horizontal asymptote. So that was these two. That's where I got those. My horizontal asymptote was y is equal to 0. So that's a horizontal line right here. Okay, cool. Now let's draw in my intercepts. And we said that my x-intercept was none. So obviously I can't draw that. My y-intercept was 0, 1/3. So I'm just going to guesstimate it. 0, 1/3. I'm going to call that this row right here. Okay, so I'm going to call that 0, 1/3. I have it labeled here, so I don't really have to label it there, but I'm going to label it there anyway. Okay, and then if you take a look, all our other information, we've done all of these things, and so this is the only thing left. Now, from here, this is where I may need some other points. Okay, so we said that it could be any of these things. So what's happening here is when I put in my vertical asymptotes, I'm breaking the graph up into the number of pieces that I'm going to have. So 2 vertical asymptotes means there's 1, 2, 3 pieces that I'm going to be drawing. If you notice, all of these have 3 pieces, and we have to decide how those 3 pieces look. When I have 1 vertical asymptote, right, I'm breaking the graph into 2 pieces, and we're going to have, we have to have graph on either side of those. If I had 3 of them, right, what would I have? I'd have, 4 pieces. So the vertical asymptotes tells you how many pieces of graph I'm going to have. So this is going to have 3 pieces of graph. I'm going to have graph here, here, and here. And what I have to decide is what do they look like in each of these places. Okay? Okay. So sometimes we have some evidence to help us. Like I already know that somewhere in here I'm going to be here. But we already saw in the other one, like I could have something that kind of does, this, or I could have something that does this or something that does this. Okay? So I have to decide which one of those pictures this is. So how do I do that? Well, I'm going to plug in some numbers. This is where I'm using my other numbers if necessary. So we know that this is a number 1, right? So what I'm going to do is I'm going to find out what f of 1 is. So I have -2, 1 squared plus 1 minus 6. And that's going to be -2 over 2 minus 6, or -2. And that one is going to be, what, a -4? So that's going to be a 1/2, which is a little bit bigger than that, right? So it's like up here somewhere. Now, here's the thing. This is where I talked to. So that's how I'm going to do it. I could plug in the points and figure out where they are. So I would do the same thing over here, and I'd plug in -1. -2 over 2, that would be, this is a 1 minus 1 minus 6, so that would be -2 over 1 minus 7. Is that true? 1 minus 7 is 6. So that would be a 1/3, a positive 1/3, right? So that one's going to be back up here again. All right, so now we can see that this is going to be one that has a shape. Hopefully you can see right? It's going to be one that has a shape that does this. Because what has to happen? I have to be approaching infinity here, and I have to be approaching infinity here because these are the asymptotes. And here, we have to come here, and I don't know that this is actually the bottom. This is just a rough sketch. This is like close enough. It may go a little lower. It may not be quite that low. It may have a little bit different shape. But in other words, it's going to be a roundy piece in the middle, not one of these. Okay? Now, again, this is a case where if I know more, I could have avoided all of this work. Now, I already knew that it was going to be this shape because of this information. So, I don't know if you noticed, but we already said that this was true, right? There are no x-intercepts for this graph, which means if this can't cross the x-axis, it can't be this picture, and it can't be this picture, because both of those would have to cross the x-axis to happen. And I already knew that it was facing up instead of facing down, because that's another thing that could happen. We could have one that's like this, you know, something like that. I know that it's facing up because it's up here. So in order to, you know, get down, you know, to be facing down way, you'd have to cross the x-axis again. So knowing this already told me what that was, and I wouldn't have had to do any of this. So if we use our brains just a little bit, it can save you a ton of work, okay? Now, what are these two little guys on the end going to look like? We really have zero clues about that. So I think the easiest way to do that is to plug a number in. So what am I going to plug in? I'm going to plug in a 3, okay? And really, what am I trying to figure out? I'm trying to figure out if I'm going to be above this asymptote or below it, because I know that I have to be approaching this asymptote, right? That's what an asymptote means. You know, my graph has to be getting closer to there, and it's either going to be doing this or doing this. And I know it doesn't cross over here because I don't have any x-intercepts. So what am I going to do? I really just need to know if it's positive or negative, kind of. Okay? That's really what I'm checking for here in this case. Is it up here or down here? Positive or negative? So 3 squared plus 3 minus 6. And of course, this gives me a 9 plus 3 minus 6 on the bottom. And so that gives me a positive. 9 minus 6 is 3. 9 minus 6 is 3. Oh, yeah, 3. So I'm sorry. 6. I lost my mind for a minute there. So this one is negative. It's going to be down here. Which means if this has to be approaching the asymptote and this has to be approaching the asymptote and it has to go through there, then it has to be this one down here. Okay? And that's how I know it's not up here, because that came out to be a negative number. All right. Now let's put in a 1, 2, 3. Let's put in a negative 4. So f of negative 4 is going to be negative 2 over negative 4 squared is 16, negative 4 minus 6. So maybe you can see already this is going to be a negative 10, so that'll be a positive 6. So this is also going to be down here, which means that this one, or this one I guess here, it has to be approaching the asymptote. It has to be approaching the asymptote, which means that it has to be a curve that does something like this. And there's my graph. Okay? Again, I'm not going to check this until after I've already tried mine, but now let's take a look. So it's cheating if you look at the graph before you punch anything in. But if you look at it afterwards to check your work, then that's just smart. But don't look before, because that's unethical. Because you can't unsee the graph. If you see it, you know what it's going to look like, and you're going to cheat. All right, here we go. Ready? Let's see how I did. And you can see I have two curves that do this, and that curve that goes up in the middle. So there's my graph, similar to what we see here. And again, what was it? What did I say? I said, you know, it doesn't, I don't know how close it gets down here. This one kind of ends up looking almost flat in the middle. But this would be a general idea of what this picture looks like. So what things do you have to include when you are graphing these functions? You have to name all of these places, and they have to show up on the graph in this way. Okay? All right. Go ahead and try some.